Okay, forming a magic square. First things first. What is a magic square? It's an n by n matrix of distinct positive integers, where the integers are from 1 to n squared. What does that mean? So it means they're distinct, it means they're different integers, and the size of the matrix is n times n, which means if they're different integers, it goes from 1 to however many integers there are in the array, which would be n times n, n squared. In this case, 3 times 3, because it's a 3 by 3 matrix, is 9. So that's 1 to 9 is our inclusive range. What we're aiming to do in this particular instance is find a magic square from a matrix that we have by taking away or changing the integers so it turns into a magic square, it converts into a magic square. However, we want to work out the quickest way to do so. Okay, let's look at the whiteboard to explain that in more detail. So what is a magic square? Now, as you can see here, I've highlighted the first row in yellow, the first column in orange, and the first downwards diagonal line in blue. And that's because these are just a few of the examples in the whole of the matrix that prove that they all add up to the same number of 15, whichever way you look at it. 8 plus 3 plus 4, 8 plus 5 plus 2, 8 plus 1 plus 6, they all add up to 15. So that's what a magic square is. It essentially shows that whatever way you look at it, all of the numbers in each of the rows, columns, and diagonals will add up to the same number. How do we work out what a magic square should look like? Well, as we mentioned prior, the numbers, the integers within the matrix are in the range of 1 to 9, distinctly. That means they are, in any case, in any way arranged, 1, 2, 3, 4, 5, 6, 7, 8, 9. A good way to work out what the magic constant should be is taking all of these numbers, adding them all up, which is 45, and then dividing by the 3 in terms of looking at rows or columns, and knowing 45 divided by 3 is going to be equal to 15. With that in mind, where we think the numbers must all add up to 15, we've first got to think about what three numbers, because we're looking at 3 by 3 matrix, what numbers from 1 to 9, all distinct, add up to 15. One of the easiest ways to think about this is first to think, well, these numbers here, they add up to 10, they sum to 10. 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6. You're going to remember these numbers from when you were 10 years old or younger learning maths. These are the most common additions. This makes it a lot easier to think about. There's only one number, number 5 over here on its own, that's left. So what we think about, right, is imagine 5 is the center of our matrix, and the other 8 numbers that we have here would dot around. They will be the outside, the corners, and the side pieces to our matrix, because it makes sense that these are the numbers which add up to 10 would surround the 5, so that when they add up together in each line, they equal 15. Let's start with an example by taking the 1 and the 9 and putting it here. So now the diagonal line, must add up to 15, because you've got the 1 and the 9 which add up to 10, and the 5. This is very self-explanatory for someone like you who's probably quite good at maths. This is easy. What the difficult part is, if there is a difficult part, is rearranging these numbers to put them in the right place, along with all the others, to find out what a magic square is going to be. Because just because you have 1 and 9 here, you can't have 8 and 6 here with the 4 and the 2 here, because this particular column would not add up to 15. So you've got to think about that, take that into account as well. So we can put 8 here and 2 here, for example, because the 5 has to be in the middle of them. We could put the 3 here and the 7 here, because the 5 is in the middle, and then the last one there, put the 4 up here and the 6 down here, because 5 is in the middle. We know that each way around they're going to add up to 15. Now, does that also account for the top one and the bottom one? Okay, so 7 plus 6 is 13, plus 2 is 15. Perfect. 3 plus 4 is 7, 7 plus 8 is 15. Same concept down here. 8 plus 6 is 14, plus 1 is 15. 9 plus 2 is 11, plus 4 is 15. Okay, so this is a magic matrix, because we have a magic constant everywhere we look. Okay, I hope that clears up the maths a little bit for you, because once you've got this idea, then you can start to think there are only a certain amount of magic matrices, out there. In fact, there are only 8 when you look at a 3 by 3 matrix, when all the numbers are distinct. There's only 8 different permutations of how it can look. Now, if you think about that, there's only 8 that are there. You can have these 8, store them in a series of array lists, and then you can compare whatever the particular array list we have from the question against each one and see which one has the most cost to change to one of our correct array lists, our correct magic matrices. Let's look at that in the code. We're looking for 8 different permutations of magic matrices. Boom. These are the 8. These are the only 8 possible placements of numbers within an array that can match a magic matrix when it's a 3 by 3 matrix. So these are your 8. I've put them in here for the sake of the tutorial, nice and easy, straight up. But if you, based on the learning we've already done, it makes sense as to why they're like this. So what's next? Next, we want to create a list of all the costs. Because the point of the question is that we're going to check each one of these arrays against the existing array that we've been provided, the input, and work out a cost for each one. Essentially, the cost for this one, if we had to go from our input array to this, that would come up here. And then for the second one, and the third one, the fourth one. And then we have a series of costs, and all we have to do essentially is look at the lowest cost out of all of them, and therefore that's the particular array that we want. Or in this case, we're only actually outputting the lowest possible cost. That's what we're trying to output. We don't even need to output the particular array, okay? Next, as we're going to be iterating over 8 different arrays, I'm going to type a little for loop, an iteration, for int I equals 0, where I is smaller than 8, because obviously we're going to iterate over 8 different arrays, I++. We also had to initialize our lists, a set of matrices here. I'm going to call it T, and it's going to be a list of lists, a nested list. But then also, we've got to iterate over these lists. So how do we do that? Okay, so these are our 3 repetitions. What does this mean? We're essentially giving a cost for each change. We look at this, whatever this number is in this particular one, so ti, if I is 0, we look at the first one, and ti0 index 0, which is going to be this one here. If that particular number, because that's what that's getting the value, if that number 4 minus our input array dot get 0, meaning the first row, and then dot get 0, which means the first number in that row, first value. If, for example, that was 4, that would be 4 minus 4, and we know that would be 0. Therefore, the first initial part would add a cost of 0. But depending on what it is, it could be 8, it could be 9, it could be 1, it could be 2. What we do is we find the absolute cost. So what math absolute does is it takes whether it's a minus or a plus, and it returns the absolute value. It doesn't matter whether it's negative or positive. Okay? So that's what we find. We find the cost. And it happens 3 times because it's a 3 by 3 matrix, but then it also has to happen 3 times for each of the rows, so each of the columns and for each of the rows. That's essentially what we're doing here. But then obviously you've got to return an output. So you've got to return the costs, right? Well, actually you don't just return the costs. What you've got to do is use arrays.sort. And you sort costs. And what this will give you is the values will be sorted based on which one's the highest, which one's the lowest. And therefore you want to extrapolate index number 0 because that will be the lowest particular cost. So when you return it, return costs index 0. And what they'll give you is the lowest cost. Okay, so let's run that. Beautiful, congratulations, it passed. So our output was 1 because that's the lowest particular cost of changing something within this input to get a magic matrix. Submit that code. Perfect, all works. So let's have a look one last time. That is our code. I hope that made sense.